Hi guys, in today's video we are going to see few problems based on the concept that we have seen so far in chemical kinetics. So just recall all the formulae that we have learned and the concepts that we studied in the previous videos. So the first question, the decomposition of N2O5 in CCl4 solution follows the first order rate law. The concentrations of N2O5 measured at different intervals are given below. So they are giving you a reaction which is a decomposition of N2O5 in CCl4, and that reaction follows first order rate law. So that's a hint given regarding the order of the chemical reaction. And they have given you the concentrations of N2O5 at different intervals of time. So look at this, time in second and the concentration of the reactant N2O5, which is given in mole per liter. So when the time was 0, N2O5 was 5.5 mole per liter, which means this is the initial concentration of N2O5. And at 80 seconds, the concentration becomes 5.0. And at 160 seconds, 4.8. At 410 seconds, 4.0. And at 600 seconds, the concentration of N2O5 is 3.4 mole per liter. Same way at 1130 seconds and 1720 seconds, they have given you the concentration of N2O5. So this is the initial concentration of N2O5 and this is the concentration at 1720. Now the question is, calculate the rate constant at t is equal to 410 second and t is equal to 1130 seconds. So you have to calculate the rate constant. What is rate constant? K value. And what is the formula to find out K value? For that, you should know what type of reaction is this, whether this is a first order or a second order or a zero order reaction. Already it is given, it is a first order equation reaction. So this is the formula that we will be using to calculate the rate constant. K is equal to 2.303 by T log A by A minus X. So K is the rate constant and T is the time. So at what time they are asking you the rate constant? 410 second. So here instead of T you can put either 410 seconds or 1130 seconds. And what is A? A is the initial concentration of the reactant and the reactant is N2O5. So this is N2O5 naught, which means the initial concentration of N2O5. What is A minus X? A minus X is the remaining concentration of the reactant. So at time T, what is the amount of N2O5 remaining? So N2O5 T. That is the concentration of the N2O5 remaining at T seconds. So now at T is equal to 410 second, K is equal to 2.303 divided by what is T? You're supposed to put 410 second. See, when you're substituting the values in the formula, make sure you're writing all the units. Log, what is A? A is initial concentration of N2O5, which is 5.5, divided by what is A minus X? N2O5 concentration at time 410 seconds. So at 410 seconds, what is the concentration of N2O5? 4.0. So here you get 4.0. So when you solve this, you will get 7.768 into 10 to the power minus 4 second inverse. See, you're finding out the rate constant of a first order reaction. So recall, what is the unit of rate constant for a first order reaction? Second inverse. So when you do this calculation, finally you're getting second inverse as the unit of rate constant. Now the next calculation, at t is equal to 1130 second, K is equal to 2.303 divided by, instead of T, what you're going to put? 1130 second log A is the initial concentration of N2O5, which is 5.5, divided by A minus X. So what is the amount of N2O5 when T is equal to 1130 second? See, it is 2.4. So put that 2.4 here and do the calculation. You're getting 7.341 into 10 to the power minus 4 second inverse. So you have found the rate constant at time T is 410 second and when time T is equal to 1130 seconds. Now the second question. For the chemical reaction A plus 2B giving 2C plus D, the experimentally determined information has been tabulated below. So they have given you a chemical reaction and they have given you some experimentally determined information. So you are doing some experiment taking A and B as the reactants. First experiment, you are taking the initial concentration of A to be 0.30. A naught means initial concentration of A, B naught is initial concentration of B, and this is the initial rate. So in the first experiment, you are taking 0.30 mole liter inverse of A and 0.30 mole liter inverse of B. At that time, the rate of the reaction is found to be 0.096. In the second experiment, you are taking the concentration of A to be 0.60, initial concentration. You are starting the reaction with this concentration of A. And for B, you are taking this concentration, 0.30. At that experiment, initial rate is found to be 0.384. In the third experiment, initial concentration of A is taken to be 0.30 and B to be 0.60, and the initial rate is found to be 0.192. And at the fourth experiment, the initial concentration of A is 0.60 and B is 0.60 and the rate is found to be 0.768. After giving these experimentally determined information, they are asking you 4 questions. First one is calculate the order with respect to A and B. Second question, write the expression for rate law. Third question, calculate the value of rate constant, which is K. Fourth question, write the expression for the rate of the reaction in terms of A and C. So these are the 4 questions asked from these data given. So let's try to solve one by one. So the first question, calculate the order with respect to A and B. So first we have to write the rate law. Let us consider the rate law expression to be rate is equal to rate constant into A per x, B per y, because we don't know the order. So we are taking it to be x and y, x with respect to A and y with respect to B. So we are formulating a rate law expression. Now they have given you these details. From this you can write the rate of all the 4 experiments. See, first rate, what is the rate given? 0.096 is equal to K into, what is the concentration of A when you have this initial rate? 0.30. Put 0.30 per x. And in the same experiment, what is the concentration of B? 0.30. So substitute here 0.30 per y. Let's take this equation to be 1. So we are taking this as the rate expression and we are substituting these values one by one for all these experiments. So for first experiment, this is the rate. And for the second experiment, what is the rate? 0.384. So 0.384 is equal to K into concentration of A per x into concentration of B per y. So 0.60 per x, 0.30 per y. So let's take this as equation 2. Same way for the third experiment, 0.192 is equal to K into 0.30 per x, 0.60 per y. And 0.78 is equal to, for the fourth experiment, K into 0.60 per x into 0.60 per y. Let's take this equation to be 4. Now, we are going to do 2 steps. One, you are going to divide equation 2 by 1 and equation 3 by 1. So this is equation 2. You are going to divide this equation by equation 1. Same way you are going to divide this equation by equation 1. You can do with 4 also. You can do all the equations you can divide it by equation 1. But we are going to do only for 2 equations. So first we are dividing equation 2 by equation 1. See, 0.384 by 0.096. When you cancel this, you will get 4. So if you're having some trouble in doing this calculation with decimals, multiply this and this by 1000. So you will get 384 divided by 96. So that gives you 4. So here k and k gets cancelled. Here you have 0.60. When you cancel this, you will get 2. See, both have the same pass. So you can write 0.60 divided by 0.30 whole power x. Or you can write 60 by 30 power x. So that gives you 2 power x. So you're writing 2 power x here. And this gets cancelled. 0.30 per y by 0.30 per y, they get cancelled. So finally you're getting 4 is equal to 2 power x. So this 4 can be written as 2 power 2. So 2 power 2 is equal to 2 power x. So this shows x is equal to 2. So keep it as such. Now in the second step, you're going to divide equation 3 by equation 1. We get, see, this is equation 3 and you're dividing this by equation 1. So when you cancel this, you will get 2. 192 divided by 96 gives you 2, and this gets cancelled. Both are same. And again here you will get 2 power y. So finally you're getting 2 is equal to 2 power y. So this can be written as 2 power 1 is equal to 2 power y. So that gives you a value of 1 for y. So y is equal to 1. And in the rate expression, we have written rate is equal to k into concentration of A power x into concentration of B power y. What is x and y? X is the order with respect to A and y is the order with respect to B. So what is the value of x? It is 2. So order with respect to A is equal to 2 and order with respect to B is equal to 1, because y value we found it to be 1. So this is the first question. What was the first question? Calculate the order with respect to A and B. So this is how we have to calculate the order. And the second question, write the expression for rate law. Just now we found out order of order of the reaction with respect to A is 2 and with respect to B is 1. So how can you write the rate law? Rate is equal to K concentration of A power 2 concentration of B power 1. So this is the expression for rate law. And the third question, calculate the value of rate constant, which means they are asking you to calculate the K value. So from this you can derive this expression. K is equal to rate divided by concentration of A power 2 concentration of B power 1. So K is equal to, see, when we started this question, we had a list of information, experimentally determined information. In that we had concentration of A, which is initial concentration of A, initial concentration of B and the initial rate. So you can choose any one of the experiments and you can substitute those values here. I mean this one. So here you can take the rate, this rate, and take the concentration of A and B here. Or you can take this rate and the concentration of A and B here. So any of this. So here we are taking the concentration of the first experiment. So what is the rate? It is 0.096. So substitute 0.096 divided by, so in this rate, what is the concentration of A and B? 0.30 and 0.30. So put 0.30 whole square into 0.30 per 1. So you are getting an answer of 3.56. And that is the value of rate constant. And remember one more thing, you can write the rate constant without units also. Since it's a constant, you can write it without units also. But if the unit is given, then you can find out whether it's a first order or second order. Same way, if the order is given, then you can write the units from that also, or you can leave it as such like this. Can you say what order reaction is this? Because we don't know the unit of K, but still you can find out the order from this. You have to add up these two parts. 2 plus 1 gives you 3. So this is a third order reaction. And the fourth question, write the expression for the rate of reaction in terms of A and C. And the equation given in the question is, see, A plus 2B gives 2C plus D. So with respect to A, you can write minus dA by dt because you don't have any coefficient. But in terms of C, you have 2 as the coefficient. So minus dA by dt. Why do we put this minus? Because to represent the decrease in concentration of the reactant is equal to 1 by 2. Why do you put this 1 by 2? Because we have 2 here. So 1 by 2 d concentration of C by dt. So this is the expression for the rate of the reaction in terms of A and C. So from a data given, we have answered 4 different questions. Now we will move on to the next question. The rate constant of a reaction with respect to the reactant A is 6-minute inverse. If we start with concentration of A is equal to 0.8 mole inverse, when would concentration of A reach the value of 0.08 mole inverse? So let's read the question again. The rate constant of a reaction with respect to the reactant A is 6-minute inverse. So the reactant here is A and the rate constant for that reaction is 6-minute inverse. If we start with concentration of A to be 0.8 mole inverse, so when you are starting the reaction, what is the concentration of A, which means the initial concentration of A, it is 0.8 mole inverse. Now the question is, when we will reach the concentration of A to be 0.08 mole inverse, which means they're asking you the time taken to convert the concentration of A from 0.8 mole inverse to 0.08 mole inverse. So what formula we can use to find out T? For that, we should identify whether this reaction is zero order or first order. From the unit of rate constant, you can say this is a first order reaction because minute inverse or second inverse is the unit for first order rate constant. So we are going to use the first order integrated rate equation. T is equal to 2.303 by K log A by A minus X. You should mention this. For the first order reaction, then you have to write this. You are supposed to find out T. K is given here. A is the initial concentration, which is 0.8. What is A minus X? Amount remaining. So what is the amount remaining as per the question? 0.08 is the amount remaining. So this is not the amount reacted, which means that gives you the X value. This is the amount remaining, amount of A remaining. So A is equal to this A. A is equal to 0.8 mole inverse. A minus X is equal to 0.08 mole liter inverse and K is equal to 6-minute inverse. So substitute all the values. T is equal to 2.303 by 6-minute inverse log 0.8 mole liter inverse divided by 0.08 mole liter inverse. So that gives you 10. This, when you cancel this, you get 10. That's log 10. So finding out the value of log 10, which is equal to 1, and then you do the calculation, you get 0.38 minute. This minute inverse goes to the numerator minute. So the time taken for the conversion is 0.38 minute. And the next question, a first order reaction is found to have a rate constant K is equal to 5.5 into 10 to the power minus 14 second inverse. Find the half-life. What is the formula to find out the half-life? This is a first order reaction and the formula is T half is equal to 0.693 by K. They have given you the K value. So 0.693 by 5.5 into 10 to the power minus 14 second inverse. So when you do the calculation, you're getting 1.26 into 10 to the power 13 second. So if you remember all the formulae, then you can substitute the values given and you can find the answer. Here I have given you one more formula. For a first order reaction, amount of reactant left after n half-life periods is equal to initial concentration of the reactant divided by 2 power n, which means sometimes they'll ask you the initial concentration of the reactant is 0.8 mole liter inverse. After 3 half-life periods, what will be the concentration of reactant left? Or after 4 half-life periods or after 6 half-life periods. In such cases, you can take the initial concentration, divide that by 2 power the number of half-lives given. So if you do this calculation, you can find out the amount of reactant left after the given number of half-life periods. So you try to solve few book back exercises based on the problems that we have seen in today's video. In the next video, I'll solve few more problems. Thank you.